Hi, I'm going to show you how to click particles on a membrane. So we're going to parameterize the membrane and then we are going to show how to use this parameterization to distribute particles on top of it. Let's proceed with the example. So in this folder we don't have anything other than a tomogram. Actually it's a small tomogram so that we do not need to do anything special with the size. We do not need to bin it. We can just open it with Tomoslice, DTM slice, bacterium rec, and well, we see that's what we have. It's a bacterium. And imagine we want to parameterize this membrane and crop particles out of it. First, let me fix the contrast. Okay. Now we are going to select a montage view of this tomogram. Basically, we just choose to create a full depiction of the scene. So that is slice at height 1, at height 21, 41, and we can just create particle points there just to parameterize the membrane. So we go to the model pool and we create a model of type surface. And now we have to feed the model. Basically, we connect the clicking system and we click on particles on the membrane. Tick, tick, tick. We can use a semi-automatic method to track the particles from slice to slice, but well, that's a very small tomogram. We're probably better off just clicking the particles. Well, this particle here should be moved with M. If you want to delete your last particle, I think you just can click on D and it will disappear, or any other particle, not just the last one. But well, we have already our membrane defined by user input. We can show it, we can show the situation of the model. Actually, we can select one interior point of the membrane because we needed to give orientation to the membrane. We have to tell Dynamo what is inside and what is outside. So that, for instance, we select this arbitrary point in the middle of the bacterium with Shift C, and that's it. That's the center, or that's a point that marks the interior. Okay, we can just edit this model. We just select these two commands just to tell Dynamo that the points are in different levels defined on Z, and this command to let Dynamo organize the points. Okay, and now we go to a step-by-step definition of the points. So we go to this step-by-step workflow. Where we do not have a lot of things to do. First, we create control points, interval between control points 20. Let's see what it means. Those are the points that we created, and Dynamo created this interpolation that is going to be used for a triangulation now. So create a mesh. Let's see how the mesh looks like. Well, looks normal. We can create a smoother version, and we can define distances on this smoother version. As we can create distances, we create a mesh for cropping. So here we put the typical distances between the particles where we want to crop them. So let's see it. You see that this mesh with the actual particles is defined in terms of the original mesh that we created first. So we can just tell Dynamo that everything is okay and view the table with the points and the orientations. So that you see, we just told Dynamo to start on the green points that we created, and step by step we define first a manifold, a surface that defines the membrane itself, smooth one, and then we create a cropping mesh where the particles are regularly distributed, and with this command, with the table, we told Dynamo to create an actual table, metadata. So let's see how it works. So save the resulting model into the catalog, and we can get rid of all these windows that we do not need anymore, and we can go to the active model and look how the particles look like. Crop particles. Let's put a side length of just 48 probably. Start cropping, and it's going to crop the 75 particles that were defined, regularly distributed on this membrane. Some of them are probably not going to be created because we are using this option here. Allow padding is switched to off, so that the particles that are too close to the membrane are going to get discarded. So the result will appear in this window. Excluded particles, well, only 3, most of them were actually created, and we can check the result. If we take a look from the X direction, so we connect all the particles and show them. It shouldn't take that much, they are small particles, we have 72. Yeah, you see what happens. And what we are doing here is using the view X. The view X of each particle should be orthogonal to the normal. That's how the membrane model works. And well, it kind of works. If we selected the Z view, the particles are going to look stranger, but they are still there. Basically, if we choose to see one aligned particle, not all of them, we see how it looks like. From X, Y, you see that the membrane is normal to the Z direction, that would be the Z direction. And in Z, well, you see that the intensity is concentrated in some slices. We could even try to make an average, because we have our data folder and our table. So compute the average of this data folder that we created with the cropping using this table, which is just an approximation to the first orientation. So we control click on the created file and just view it. Yeah, that is what we would expect. That is the average membrane in the points where we have cropped it. Okay, that's all. Thank you for listening.